Hello everyone, welcome to the 10th episode of the DevStandup. And guys, as you know that every week we feature one developer or IT specialist from the industry to share their experience. And I'm really happy that during this marathon we have hosted a lot of bright minds across the world, and Simon is one of them. So Simon, a little bit of introduction about himself, has over 23 years of experience in technology, starting out as a software engineer before moving to professional services, and for the past decade excelling in the technical pre-sales. He has helped some of the world's largest banks modernize their application, and especially passionate about the distributing system with a strong focus on API management and service mesh technologies. And currently, Simon is a principal solutions architect at Red Hat. So about his topic, he's going to talk about the long-running action and durable execution. How can this help the cloud migration, which is going to mainly focus on, as you know, organization migrate stateful and transactional systems to distributed microservices or cloud-native architectures. The SAGA pattern play a key role there. So in this discussion, we will look at where the SAGA helps and how the customers are applying it today. So I think it's a really interesting topic, and without wasting any time, I would like to hand over the microphone to Simon, and he can start his presentation. So here you are, Simon.
Thank you very much, Eleanor, and nice to meet everyone. Simon Green, and as Eleanor mentioned, I'm going to talk about distributed transactions, I guess, long-running actions, and how they can help with migrating workloads over to the cloud. So I'm going to start off with some fundamentals, right? None of this should be new to anyone that's worked in technology. This is computer science 101. Let's just go back to what a transaction is, right? And we started with local transactions. So this is back in the days when we had mainframes or big monolithic databases like Oracle and SQL Server, name your database basically. What we needed to do is protect things like data integrity and consistency. So if there was any kind of read or write, that we can kind of protect that integrity and consistency so it doesn't get corrupted. And we used to talk about this acronym called ACID, so atomic, consistent, isolated, and durable. That was really key, okay? Now this was actually pretty easy because at that point in time, we just delegated that all to the database. We just said, Oracle or SQL Server, you deal with transactions, you figure it out, and our applications didn't really need to worry about it too much. So it was a pretty good solution, but we're just dealing with one single source of truth, which was the database. So from there was a bit of an evolution. We introduced something called XA transactions. And XA transactions is where we have two sources of truth, two or more sources of truth. So in this case, it could be, say, a database and a messaging queue. And what we get into now is this kind of two-phase commit protocol that we need to manage. So committing to multiple data sources all at the same time. And the way that we do that is we have to introduce new actors. In this case, a transaction manager and a resource manager that kind of helps orchestrate the commitment of that read or write operation, whatever it might be, to the database. Okay, and this is a very, very useful pattern that is really the backbone of financial services. If you think back to, I keep bringing up the mainframe, but back, when we were working with mainframes and what have you, IBM had things like CICS transaction gateways, for instance. So they really did a good job at receiving requests from producers, producing applications, and making sure that the transactions were committed in the correct order. So moving on, as Eleanor mentioned, I kind of started my career in software engineering, but as I got into consulting and started working more with banks and financial services, I started using this framework called Apache Camel, which is a really, really cool Java-based framework for implementing what we call enterprise integration patterns. So things like file-based routing, content-based routing, basically routing a request from A to B. Apache Camel was really good at doing that. And one particular pattern that it also excelled at was both local and global transactions. In fact, we had this pattern called the Transaction Client Enterprise Integration Pattern, or EIP. So Camel itself is aligned very closely to 50 or so EIPs that are actually out there in the wild. And in this particular case, the transactional client EIP was a really easy way for Java programmers to make their code transactional in less than 4 lines of code. And in this particular example, we have what we call an idempotent consumer. So what that means is the file consumes this that first line of Java code. It consumes, say, an XML file from disk and reads it only once. It doesn't move it to any kind of backup directory or anything, just consumes the contents of that file. And then we have various operations that we need to commit to a particular bean. So in this case, we need to credit an account with a particular amount and then debit another account from the sending institution. And because it's wrapped in this transacted tag, that essentially makes this chunk of code transactional. So really, really useful framework for doing anything that's kind of transactional. So as with anything, there's always trade-offs and things that we have to deal with. And unfortunately with Camel, it hasn't really done a good job at moving things over to the cloud or dealing with cloud-based workloads. Now there's folks in engineering that might disagree with me there, but for me, it feels like it hasn't really evolved. Similar to the same way that, say, the Spring framework hasn't really evolved either. There are, projects like Spring Cloud and what have you, but Spring transactions and I guess Spring integration haven't really evolved that well. And the problem is, there's just so many challenges in the cloud. It's so different to running workloads on premise. So you're introducing network challenges. No more dealing with things like, like the traditional DMZ and trusted zone like we used to have in the old days. Now everything's distributed and basically you have an adversarial network that you have to deal with. The other thing is storage complexities that you have to deal with. And the big problem that we also have is having multiple services, like microservices, for instance, running in different geographical locations. So having to deal with that presents a lot of challenges. So the question you might have is, how can we solve that? And how has transactionality evolved beyond the good old days of doing local transactions and XA? And the answer is the SAGA pattern. Now, the SAGA pattern has actually been around for a while. It's probably been around for, 15 or so years. And like many things, it comes in many different flavors. Well, in this case, a couple of different flavors. The first one is the orchestrator flavor. And for me, this one is very, very, very similar to what we did with transaction and resource managers. So in this particular example, you have a user going to a website, wanting to order something. They click order. You have an order service that you've created, which triggers what we call a SAGA. And that SAGA command goes to the SAGA orchestrator. And from this point onwards, the orchestrator is responsible for coordinating the events between the different services that we rely upon. So in this case, we have to send a command to the payment service. Then once that completes, the orchestrator sends another command to the shipping service. And if everything is great, everything communicates and executes correctly, then the orchestrator or the SAGA orchestrator will issue a command to the database to commit that particular order and make sure that it's it's correct. So that works really well. Now, if it didn't work so well, just say for instance there was an issue with the shipping service and there were lots of retries and it wasn't working, you have something called compensation. So it's up to the SAGA orchestrator to be able to compensate the different services. So for instance, it could reverse the credit debit commands on the payment service and actually roll back the payment, for instance, and also produce an error message, issue a command to the order service to produce an error message back to the user. So you get the idea. It's very much like transaction management that we would have done on premise, except we're using something called an orchestrator. And yeah, it has many different pros and cons. So big one is the separation of concerns. It's really well suited for microservices where you have services, a big monolithic application decomposed into many different services, for instance. But the downside of this, like with having a transaction manager, is the single point of failure. What happens if the orchestrator goes down? What are you going to do? It's basically going to break your whole model. So as we move on, the other flavor, I guess, of the SAGA pattern is the choreography flavor. And for this one, this is very similar to what we used to do with Camel. And that is make use of durable messaging queues. So in this case, the order service issues a command to the payment service. So it could be JMS, for instance. The queue should be durable so that in the event that the queuing mechanism or the broker goes down, once it comes back up, the message can continue. And then messages basically get passed from service to service. Now, the pros of this is it's incredibly simple. It's a lot simpler than, say, using an orchestrator or modifying your code to have to integrate with an orchestrator. But then there are things like the cyclic dependencies, which pose a problem. If the payment service breaks down, then that kind of interrupts the shipping service, for instance. And the other thing is everything is now kind of tightly coupled. So now we're back to more of a monolithic architecture in a way. Having said that, it is a simpler solution. You don't have that single point of failure like you do with the orchestrator. So what kind of implementations are out there? So these are the two that I know of that I've played around with. One is called Temporal. I used Temporal probably a couple of years ago for a startup that I was working with who discovered this. We needed to modernize some of our Apache Camel routes to be a little bit more cloud native, run on Kubernetes, but still be transactional. And we used Temporal for that because it had really good observability. It had an orchestrator to help kind of manage all of those difficult camel routes and basically keep everything in check. So Temporal is a good example of kind of the orchestrator SAGA pattern. For the choreography SAGA pattern, the one that I've come across is DBoss. So this is where you embed logic directly into your code. It has an SDK for, I think, TypeScript and I forget the other one. I think it's Python, but more on the way. And this is very much a lighter weight framework. So depending on your use case, one of these implementations might be able to help. So in terms of the typical use cases that I see for SAGA pattern, you see the stereotypical transactional stuff like payment processing, the e-commerce retail sites, websites, for instance. Other use cases could be around business processes. So things like, orders, logistics, marketing campaigns, that kind of thing. Mortgage underwriting, I see that a lot. But the one that I'm most interested in is its use for custom CI/CD. I think this is a really interesting one because people get into big trouble trying to juggle things like Terraform and Ansible and GitHub Actions and kind of piecing it all together and throwing in Argo CD at the end, right? So for CI/CD, I find this a really, really interesting use case. So I'm going to talk about this next. This is actually a use case that my customer that I have at the moment, it's a tier 1 bank here in the States. They had an issue, well, it wasn't an issue, it was a challenge of deploying different greenfield containerized apps to the cloud. So they have they just use 2 hyperscalers, but they want to be able to have a cloud agnostic way of deploying and using Git Actions. So what we found is Git Actions does a really, really good job at running CI/CD tasks. So things like testing, building, deploying, etc. But once you get into kind of a need to coordinate or get some observability features in, things start to deteriorate really, really fast. So dispatching across multiple repos, handling long-running jobs, or recovering gracefully from failure aren't automatically built into GitHub Actions, right? Unless you're using some kind of controller. So that's exactly why you need orchestration, right? It's a way to trigger, track, and manage those Git actions as part of a bigger, more reliable system, right? And in this case, my customer calls it their Cloud Shim. So by combining GitHub Actions, and in this case, Temporal, my customer created a CI/CD system that was able to scale with their needs, but survive those failures without any kind of slapdash efforts to patch things up. So what we noticed is the integration with Temporal kind of created this really nice, clear separation of duties. So you have GitHub Actions to handle the actual CI/CD work, the stuff that it's good at. And then you had temporal workflows to help orchestrate and help with actually executing the Git actions themselves, but with reliable execution guarantees. So what this enabled was complex coordination. You're able to chain multiple actions across repositories. We had reliable execution, so automatic retries and failure handling. We had observability, end-to-end observability of the whole GitHub action kind of workflow. And then we were able to deal with things like long-running processes. So this is really important. When you're dealing with infrastructure as code like Pulumi or Terraform, some of those jobs can take hours to run, to spin up infra. The same goes for Ansible for configuration management. When you're configuring and installing apps, those playbooks can take some time. So what we needed to do was wait for those actions that take hours without any timeouts and have temporal kind of coordinate and orchestrate that all as one large workflow. So really interesting use case. Really enjoyed working with the customer on this. Just to kind of recap what I talked about. So I kind of looked at the way that transactionality has evolved from the traditional local transactions that we used to have with the database to kind of XA transactions to something that's more kind of cloud native friendly. So using the SAGA pattern, in which case we have both the orchestrator flavor and the choreograph flavor, just depending on what use case you have. And then a really good practical use case for applying the SAGA pattern. So in this case for CI/CD, we applied it, we used an orchestrator from Temporal to help coordinate all of those particular individual GitHub actions and tasks. So that's basically all I had to chat about today, folks. Did you have any questions, Elna and Ali?
Yeah, thanks a lot, Simon, for great insights about this. Atakan, you can start giving your questions, and I will ask my question.
Yeah, I have a question. So it was more about, it was a very interesting topic, especially the Saga pattern. I wanted to ask about what about the rollbacks? Is it built into this pattern or to this orchestrator, or if it's not a reverse a same pattern but then the reverse way can be applied, a fail forward kind of scenario?
Yeah, no, that's a really good question. So with the Saga pattern, the terminology for rollback is compensating action. So basically, the orchestrator, or if you're using the choreograph version, you have to build in some kind of code as a compensating action. So what happens if it fails? You would catch the exception and then execute that compensating action. So that's kind of built into that particular pattern.
Thank you.
Yeah, excellent question though.
I will ask a question regarding my field, as an SRE. So let's say as a Saga pattern, how do you differentiate between this expected compensation and the actual business failures when monitoring this Saga pattern?
Yeah, so you have to feed back what complete means, and that has to be kind of integrated into the orchestration. So it's kind of dictated by the pattern what that looks like. What does complete mean? The other thing that's really nice is you can, in this case with the Git actions, for instance, you're able to kind of trigger Git actions from some other external scheduler, for instance. I forget which scheduler they use, but you could take the kind of correlation ID from that scheduler and include that in the Git actions. So for every single Git action that you run, you can use that as a correlation ID, and then you can use that as a searchable entity in your observability platform as well, which is really, really nice.
Okay, and also let's say you mentioned that this playbooks can take really long hours, right? Let's say if you as an developer or basically the person who makes these deployments, let's say in the middle of pipeline basically has some problem, then how you are compensating this issue that after that this Saga pattern will work basically flawless.
Yeah, so you need to have some kind of retry timeout logic. The only difference is it's stuff that a developer would typically build into their code, but you're offloading that responsibility to the orchestrator instead. and kind of centralizing it in the orchestrator instead.
Okay. And about this, you mentioned about this choreography and orchestration. Like, how do you basically decide between these patterns? Like, when to choose, like, which one? Like, do you have any trades-off for this, like in real-world examples, or like what are your methodologies, like choosing which one to use?
Yeah, I guess I'm most familiar with the choreography-based one because that goes back to kind of the way that we used to use messaging queues, like traditional messaging brokers, which is fire and forget. It's just asynchronous command, tell system A, tell system B, go and do X, Y, and Z. That seems to work pretty well, like between, say, a messaging queue and a database, or an application and a database where you have, I don't know, web sharing queue in between. I think when workflows get a little bit more complicated, when there's human intervention, where there might be approvals necessary, if there's long-running actions, like in this case, like running Terraform or something, then the orchestrator flavor of SAGA would probably be more useful. But then you've got the trade-off there is the single point of failure with the orchestrator that you need to take into account.
Okay. Atakan, do you have any more questions?
Yeah, I just have one last one also related to this. Like, this pattern can be applied to like a parallel actions, or it needs to be always sequential because of the transactional nature of it?
Yeah, I think that's the other point. So with the orchestrator, it can be parallel. So that's kind of going to help with scale, right? It doesn't have to be sequential. So I think, the orchestrator pattern is kind of favored when you want to be able to scale out what you're trying to do, what you're trying to build.
Thank you.
Excellent questions, folks.
All right. Simon, thanks a lot again, like for this really nice topic. I hope that like in the world, like I say, like other people, like developers also using such patterns, and it will be also useful for them, like they can apply in their work. And guys, that was it from Simon's side and about his topic. I hope that it will help other people also, like in their work. And if you want to be like our next guest speaker, we have the form under this description below of every video. So if you have any topic you would like to share with other people, please fill in the form, and then our team will contact you and you can be our next guest speaker. So apart from that, thanks a lot, and bye-bye everyone. See you in our next DevStandup. Bye.